Today we're going to talk about the app data analytics system design by leveraging different type of the big data analytics tool and also the tools that is available from the Google Cloud or GCP. Right. So first thing that we need to take into consideration is how we're going to embed the data collector module that is inside the front-end app code base. Right. So after we have embedded the code with the data collector module, and then we're able to receive the data from the server end. Over here, we're going to use the Nginx as a production server, and also the Nginx server is able to write the data into a relational database, which is MySQL, that stores the production data, which contains, for example, the user information, the billing information, the stock information, etc. And how we're gonna further processing the data from the MySQL to the HDFS over here, right? So the HDFS is from the Hadoop framework, and over here definitely we need something to do the conversion, which is the scoop, right? The scoop supports ETL, and it's sort of dedicated for the kind of use cases to convert the data from the SQL format to the HDFS. So after we store the data into a distributed data store platform HDFS, we're going to process it by using MapReduce. Over here, we select the tool, which is Hive, Apache Hive, and we're going to process it into different layers, right? So for each of the layer, you're going to further complicate or simplify the data for your own use cases. And then they're going to curate the data by using the high performance Presto, or we're going to use the standard HiveQL and output it into a relational database again. You could use the MySQL DB and then visualize the data or training out a report based on the data that you already collected, processed. So over here you have a different set of the tool for different kind of use cases. And you can even use the business intelligence tool called Tableau, right, to further consume the data. So that is the entire flow for the production data analytics. And now let's look at how we're going to process the data for the logs, right? So over here, we're going to talk about two different use cases. The first one is the offline data, the batch jobs, and the second one is the real-time data streaming. So similarly, we're going to stream the data to the server, and then based on that, we're going to generate a log file, and we're going to use the Flume as a data streaming, the collection, and the consumption module that is dedicated for the HDFS. So over here, you'll be asking, hey, it seems Flume is pretty powerful. It can surface the requirement. Why we still need a Kafka over here, right? The reason is not just the offline data, the batch job need to be done, but also we need a real-time log processing for certain real-time use cases, real-time log analytics, based on, for example, the tool that is called the Spark Streaming, or we can use alternatively for by the Apache Flink as well, right? So the reason we have the Kafka over here is because we want to decouple the flow, right, from here to here. So that's why we place the analytic components Kafka for the real-time data analytics use case. And we're going to use Spark Streaming for the real-time data processing, and we're going to output it into a NoSQL, for example, the HBase. Right, so that's all for the data analytics system design overview from the architectural perspective. And now let's map it out with the GCP components. Right, so the first one is the MySQL replacement with the Cloud Spanner. Right, the Cloud Spanner is a highly performant, highly optimized MySQL solution from GCP, and we are facing the similar situation. How are we going to do the data conversion or ETL and send or stream the data into the HDFS format? We're going to use the GCP data flow that supports both real-time and offline data processing, and we're going to replace the entire Hadoop soup that includes the distributed data store, the data processing by MapReduce, and also the data query with the GCP Cloud Data Proc, and are going to output it into another relational database called the Cloud Spanner, and are going to visualize it, consume it, turn in a report by the Google or GCP Data Studio, right? So that's all for the production data. And for the log data, similarly, we're going to replace the Kafka message broker with a tool that is called the Google Cloud PubSub, similar function, and I'm going to replace the Spark Streaming and the Flume with the Cloud Data Proc and output it into a NoSQL database. And on GCP, we select the GCP Cloud Bigtable. So that's all for my explanation and presentation. Hope it's helpful. Thank you very much.